Hello guys, today we're doing LeetCode question 289, Game of Life. So the question is, according to Wikipedia's article, the game of life, also known simply as life, is a cellular automation devised by the British mathematician John Horton Conway in 1970. The board is made up of an M by N grid of cells, where each cell has an initial state, live, represented by a 1, or dead, represented by a 0. Each cell interacts with its 8 neighbors, horizontal, vertical, diagonal, using the following four rules taken from the above Wikipedia article. So rule 1. Any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. Any live cell with 2 or 3 live neighbors lives onto the next generation. Any live cell with more than 3 live neighbors dies as if by overpopulation. Any dead cell with exactly 2 live neighbors becomes a live cell as if by reproduction. The next state of the board is determined by applying the above rules simultaneously to every cell in the current state of the M by N grid board. In this process, births and deaths occur simultaneously. Given the current state of the board, update the board to reflect its next state. Note you do not need to return anything. So this means we have to update the current board in place. So let's see, here we have board 010, 001, 111, 000. Now you would think you can loop through it a little bit one by one and check if the value is surrounded by whatever and then change it. So here you can see 1 is not surrounded by 2 or more, or 3 or less, surrounded by 1, so it will die. 0, and then you go down, keep going, but this 1 is not surrounded by 1, 2, it's dead, so that remains a 0. As you can see, you can't do 1 by 1, you have to check each value in the current position and change them onto a new board, and then switch that board back to the old board, because if you change 1 by 1 it will be incorrect. You have to change them all at once, as it says here. The next state of the board is determined by applying the above rules simultaneously. So we will do this again by checking each value, creating a new board, and populating that board based on the current positions and surrounding elements. So I'll show you how we do it here. So here we have our board, and then we'll create a new board here, which is the same, and we fill everything with zeros. So 0, 0, 0, 0, 0, 0, 0. Now we start looping from the first array, from the first value in the first array. We check if it's inbounds first, or if the values beside it are inbounds, and then we check if they're surrounded by a 1. So let's check the base case. So if it's less than 2 or bigger than 3, then it becomes a 0. If it is 0 and the current value is equal to 3, then it becomes a 1. Else, everything else remains a 1 or remains a 0. So that remains the same. So we'll check here the first value of the first array. Is the value above inbounds? No. Is the value top left inbounds? No. Is the value on left inbounds? No. So we check, is the value right a 1? Yes. Is the value bottom right 1? No. Is the value below a 1? No. So this remains 0 because there's not 3 surrounding elements. So we move to the next one here. We check, are the values above inbounds? No. Is the value beside a 0? No. Is the value beside a 0? No. I forgot to mention we also can carry a count to count each value beside it. That is a 1. So we continue from that position. So we have, as you can see, just one neighbor. That is a 1 with that current value. So we set the count to 1 and we check. Now you can see the count is smaller than 2, and it is smaller than 2. So we set that value in the new grid as 0. We leave it as 0. Then we continue. Count is now 0 again. And we're in the next iteration, 0. We check, does it currently have any 3 or more surrounding elements? No, it doesn't have 3, so it remains 0. We go to the next value, 0. We check, does it have 3 surrounding elements? It does. The one top right, the one below, and one bottom right. So we set that in the new grid to a 1. Here. I'll just make that proper 1. We go to the next value. Does this array, or this value, have 3 surrounding elements? It does, but it has more than 3. And as it's not exactly 3, it remains a 0. So we go to the next value, 1. Does this value have more than 3 or less than 2 surrounding elements? It has 3 surrounding that are 1. that remains alive, we leave it as a 1. We set it as a 1 on the new board. So this is 1. Let's break that out, same 1. We continue to the next value. Now we check, is the current value surrounded by less than 2 1s or more than 3 1s? Yes, it's surrounded by only 1 1 on the value on the right. So we leave it. So we leave it as a 0 on the current array, on the new board. Sorry. Then we continue to the next value. We check, is that value surrounded by 2 or 3 1s? It is. No more, no less. So that stays live. And we set the live value here on our new array. That's now 1 here as well. So our new grid. We go to the next value. We check, is this surrounded by 2 or 3 1s? It is. So the value remains live. Surrounded by just 2, not more than 3, and not less than 2. So this value on the new board is now 1 as well. Go to the next value. This is 0. Is that value surrounded by 3 1s? No, it's not. Only by 2, so that remains 0. Go to the next value. Is that value surrounded by 3 1s? Yes, it is. All above. So we set that as a 1 in the new board. We continue. Now we're at the last value. Is that value surrounded by 3 zeros? No, it's only surrounded by 2. So we leave that value as 0 in the new board. And then we have to copy our new board into our old board and return our old board. We don't have to return it, but we have to copy it into a new board. We'll do that through another for loop and loop through each value, making them this value. So now this value comes this value switches this value switches this value, and so forth. Okay, so the first thing we do is create a new array. So let, or a new board. So let new board is equal to array dot from. We'll create a length of current board length, which is the columns or the rows, sorry. And then for each value, create another new array with length of current board's columns. So board I, board 0 dot length, because we haven't looped through, there's no I. And then we fill each value with 0. They have to loop through the array, through the grid, sorry, so get through that board. So the I is equal to 0, because I is smaller than board dot length. Then we increment. Then we loop through, so that was looping through the columns, now we loop through the rows. So for let j is equal to 0, so where's j smaller than board I dot length. Then we increment j, dot here. Then we create a count to count our current live neighbors around the current position. Then we have to check each position. We'll start from the top left and we'll go all the way around. So we'll start from top left position, which is if, check if it's inbound. So if I is bigger than 0 and j is bigger than 0 and the board value of I minus 1, j minus 1 is equal to 1. We know we have a neighbor, so we increment the count. We go to check the top value. So if I, again, is bigger than 0, that's checking if it's in bounds. We're going to check if j is in bounds, because we know we're not checking j. Actually, wait, so if I is above, yep. If I is bigger than 0, j is in bounds, is the same position. So if I is bigger than 0, and current value, so board I minus 1, j is equal to 1. We know we found another live neighbor, so we increment the count. We check if top right, so if I is smaller than board dot length minus 1, and checking if it's in bounds, and checking plus 1 has to do the same for j. So if j is smaller than board I dot length minus 1, and at current position, so board I minus 1, j minus 1 is equal to 1. Then we found another neighbor, so we increment the count. So I'm going to skip this and get all the other positions done. Pretty much checking from top left all the way around. You can do this in any order, but this is just the way I'm going to do it for you. I'm gonna skip this and I'll continue when I've done this. So okay, so I'll finish checking each neighbor. So now we have to go through the rules. So any live cell with fewer than 2 live neighbors dies, and any live cell with more than 3 live neighbors dies. So we check that. So if the current count, which represents the neighbors, is smaller than 2, or current count is bigger than 3, then we know that the neighbor is dead. So we set a position in the new board as 0. So new board I j is equal to 0. Then what's the next rule? Any live cell with more than 3 live neighbors. Okay, any live cell with 2 or 3 live neighbors lives. Any dead cell with exactly 3 live neighbors becomes a live cell. So here we check if the cell is dead. So if the current cell is dead, so if let's say, sorry, else if, so this way, else if current cell, so cell board I j is equal to 0, we check if the count is currently equal to 3, then we revive it and set it as a live cell. So we set new board with position I and j as 1. Else it just remains 0, as we already set them to 0. And otherwise, if we haven't triggered the first 2 statements, we know that the only remaining option cell is already alive and it remains as 1. So we set a position in the board I j as 1. Now let's double check. Let's console log our new board, see what it looks like compared to the solution. This won't pass, by the way, but let's just compare it. Board idle length. Oh, there's an error here. Board idle length. Okay, let's remove that. Now let's check. Defines reading man of swan. I see. So this has to be, as it's top right, should be I plus 1 and j plus 1. Sorry, I plus 1 and j plus 1, yeah. No, I minus 1 and j plus 1. So we check if j is smaller than border length. And I has to be bigger than 0. So if I is bigger than 0, it's an incorrect statement, sorry, I checked it before. That's because here we're going out of bounds further right on the j. So we check that it's in bounds smaller than the length, and we're going out of bounds smaller than the array 0 itself, so we have to check if it's bigger. Now let's see, compare the boards. Okay, let's see. Oh, something is wrong. As you can see, there's missing values for these, the first and the last value, which means our array initialization is incorrect. But as you can see, I think it's majority correct in terms of the numbers 1, 0, 1, 0, 1, 1, 0, 1, and that will be a 0. And that will be 0 there as well. So let's just fix that. Let's see, array from left, new array, left. Oh, okay. Here we just write board 0.length. Now let's run, see how that looks. See 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 0. Okay, perfect. So the board is now the correct one. So now what we have to do is loop through the array, the board again. Let's just copy and paste this just for the sake of ease. Control V, let's create the brackets. Here. Okay. And then we just set the current board position that we loop through as the new board's position, I and j. So now we set the board as a new board. Now let's run, see if that passes. Perfect. Let's submit. As you can see, time complexity beats most people, or beats everyone, and space complexity beats most people as well. Now the time complexity of this is O(n) squared, as we loop through an array of arrays, so a nested array. And the space complexity is also O(n) squared, as we're storing an array of arrays again. Thanks for watching.